Welcome to Distance Learning with Nripendra Acharya, and in this video we are going to learn about actually let me tell you that this video is for grade 8 students, and here what we are going to learn, let's see something familiar we are going to learn, that is sets. And there is a definition of sets also. You can see on your screen. A set in mathematics is a collection of well-defined. Now you have to understand what does well-defined mean and distinct object. What is well-defined? Now if you are going to construct a set of taller student in a class, so you won't be able to create a set, or you are not going to be able to form a set, because there is the criteria is not set. What height is considered as tall height, isn't it? It's not defined. Which height, from up to which height it is considered as shorter one, up to which height, the above which height is considered as taller. So the criteria is not set, so that's not a well defined. Okay, now, and distinct means one and one. A single element cannot be repeated twice. Okay, you cannot form a set uh, with the same element repeating multiple times. So that is distinct. And well defined means the criteria must be set. You cannot form a set of talented student of a school. Now the criteria is not set. Okay, isn't it? So the student from which marks is called talented. The student securing up to which grade is called talented. The criteria is not exactly set, so that is not well defined. It must be well defined. You can form a set of a student who scored GPA above 3.2, isn't it? That is well defined. 3.2 to 4, that is well defined. So what is well defined, what is not well defined, you have to understand that. So well defined means if the criteria is set correctly, if there is a set criteria for it, then it is well defined. Now, as I have given you the example, if you say the set of talented students, set of taller students, or set of uh, uh, intelligent students, there the criteria cannot be set. It is not actually set. Can be set, but it is not set in the question, so that is not well defined. And distinct means set cannot be formed with the same object to repeat it many times. It must be only one time. It must be repeated only one time, or it must be written only one time. So that is distinct object. Well defined means it must be defined properly. Like as I have already said, that set of students whose height is above 5 feet, that is well defined. Above 5 feet. Okay, 5 feet, if you can pick those students whose height is above 5 feet, that is well defined. And if you say taller student, that is not well defined. So that's the definition of set. So let's move forward. Flashback means it's like a revision what we studied in previous classes in class 7, 6, 5. Universal set. What is universal set? It is the father figure of the sets, isn't it? It's like a boss. No? It includes every other set inside itself. So universal set, usually denoted by U, is a set which has elements of all the related set without any repetition. So that means distinction. Okay, distinct. As we have already talked, as we have already discussed, what does distinct means? Mean without any repetition. So it's like a father figure which includes each and every other member of the family. Now that is universal set. Say if A and B are the two sets, such as it has the elements 1 to 3 and B has the element 1 A B C, then the universal set associated with these two sets is U 1 2 3 A B C. Now you can see U includes each and every element of set A and B. Okay, so U is universal set related to set A and B. Now union of sets, union usually denoted by U of collection of sets. Okay, collection of sets is also a set which has every element of those sets, which elements of those collection without any repetition. Now there is a similarity between a universal set and union of a set, and but they are not completely equal. Okay, we cannot say that a universal set and union of a set, the set obtained after the operation of a union, uh, some cases they may be equal, but in some cases they may not be equal. We will discuss about it in which cases uh, union of sets and universal set is not equal. Now it is also the collection of set. It is also a set, new set formed by taking the multiple sets where the elements are not, each and every elements are taken but without any repetition. Okay, it's a single set. Union of a set is also a single set formed by taking a numerous sets. Okay, by taking numerous sets, and but the elements in the sets are not repeated. You can see the set A is given as 1 3 5 7 and B is given as 1 2 4 6 7, and here each and every element are considered. You can say A union B is also a set. Each and every element are considered, but the elements are not repeated. So element won't be repeated in sets. Okay, element intersection of sets, element won't be repeated on set. You cannot repeat one element multiple times. Intersection of set, intersection of two sets A and B is the set containing all elements denoted by A. You can see here, this is the symbol for intersection, this is the symbol for union, and this is a representation of a universal set. Okay, it's not a symbol, it's a representation. It's like alphabet, but these two are operator. This union and intersection are operator. Is the set containing all elements of A that belongs to B, means in simple term we can say the common elements on both set. Common elements on both set. You know what does common means, isn't it? Same elements from both set. Same elements from both set. Or you can say equal elements from both set. Identical elements from both set. Now, these are the sets A and B, and intersection. You can see 7 is present on both sets. There is 7 on A also. There is 7 on B also. So 7 is the intersection of A and B. Intersection is simply a new set formed by taking only those elements which are common on both sets, or both or many number of sets which are under consideration. Here we have considered only two sets. So from these two sets, only 7 is present on both sets. You can see 7 is visible on both sets. 7 is identical on both sets. So okay, there is 1 also. Okay, 1 and 7 are common on both sets. 1 and 7 are present on both sets. So intersection of A and B is a new set formed by taking the common elements from the set under consideration, that is A and B right now. So this is a flashback. So let's move to another slide. Now we have to learn how to list the elements of a set. Okay, listing or representation on roster method. Also we call it roster method. Now it's written in the description form. Set of even number less than 20. So 20 is also the even number, but we are not allowed to take 20 as an element of set P, as it is described as defined as less than 20. So we have to write all those even numbers starting to less than 20. So the elements of the P will be, we'll write that. Okay, let's see the question. Set of multiple of 4 less than 20. Set of multiple of 4. Multiple of 4 means 4 ones are 4, 4 twos are 8, 4 threes are 12. In that way, that's the multiple, isn't it? So less than 20. 20 is also the multiple of 4, but we are not allowed to include 20 as it is defined less than 20. Here, x says that x is less than or equal to 4. You have to see this equal to sign here. There is equal to sign. So 4 will be included and 7 also will be included. So we have to write all the numbers from 4 to 7. Not between 4 to 7, from 4 to 7. From 4. We have to take 4 also. We have to take 7 also. So all the numbers must be included. R equal to, now again, S is equal to prime numbers. So you know what does prime number means, isn't it? So prime number is started from 2. We have to start from 2, and we have to take less than 30, that is 29 is the last prime number. So prime number is those numbers which divides only by 1 and itself. None of the other number can divide it exactly. Okay, so 1 can divide prime number, and the number itself can divide prime number. So other number cannot divide prime number. So the set S will be, so let's move to another one. So you will see the answer, but let's see the question here. X says that it is less than 3, but it is greater than 3. X is greater than 3, but less than or equal to 9. So you are not allowed to include 3 on your set, but you are allowed to include 9. Okay, so we are not allowed to include 3. That means we have to start from 4 and we have to end on 9. So the set T will be, so let's see the elements on the first set, that is 2, 4, 6, 8. 2 even number starts from 2, and we cannot end on 20 because less than 20 means 20 is not included. So that the last even number will be 18. Now in next you can see multiple of 4, 4, 8, 12, 16, and we next after 16 it is 20, but we are not allowed to take 20 because as it is defined less than 20. Now here we have to include 4 to 7, as I have already told you. 4 is included, 4, 5, 6 and 7 both end are included, 4 and 7. Prime number, it starts from 2. 1 is neither prime nor composite, so we start from 2, and 2, 3, 5, 7, 11, 13, 17, 15, 19, 23, 29. So according to the definition of prime number, the number which can be divided by 1 or the number itself is a prime number. So here 3 it cannot be included, but 9 can be included. 4, 5, 6, 7, 8 and 9. So if you learn to list these elements in this way, I think it will be enough. You can easily list from here. So it will be helpful in doing some problems. A Venn diagram. Now see, draw a Venn diagram representing these sets A and B. You can see the elements of A also, you can see the elements of B also, and you know the union, isn't it? As we have already discussed, union is a set formed by taking each and every element of set under consideration, that is A and B, but none of the element must be repeated, can be repeated. So you can see each and every element from set A and B is taken, but none of the element, see 1 is repeated, and you can see 7 is also repeated, but they are not taken. Okay, they are taken only once. So repetition of element is not allowed in a union. So let's draw the Venn diagram of a union of set. First we take a ring. I call it a ring, not a circle. Okay, let me call it a ring. So understand, this is a ring and it is a set A. Okay, you can draw a ring and you can name it as a set A. So the elements of the set A can be written in this way. So 1, 3, 5, 7 are the elements of the set A. Now what we have to do while drawing a Venn diagram, we have to take another ring also for set B. You can see here. Don't draw right here, okay? It's just to make you understood. I have drawn there. You have to draw, you have to show the final product. Okay, here there will be animation, but you have to draw the final product, the final figures, the final Venn diagram. So let us feel the elements of set B also. Elements of B you can see. But we have to consider while drawing a Venn diagram of any Venn diagram, okay? Not only A union B, A intersection B, or any other operation of sets in any other operation of set. While drawing Venn diagram, just keep in mind, are there any common elements? Are there any common elements from both sets? See, 1 is common on both sets, and 7 is also common on both sets. we have avoided writing twice, isn't it? See, we haven't written 1 and 7 twice, isn't it? 1 and 7 are written only single times without any repetition. So that's the perfect way to write A union B. But while drawing Venn diagram, you can see there is 1 and 7 on A also, there is 1 and 7 on B also. What does it mean is, it means these sets A and B are overlapping set. Means there are few elements common on both set. Few elements are common on both set. On set A also, on set B also, and those few elements we have already recognized those few elements as 1 and 7. So these 1 and 7 must not be repeated, isn't it? Here you cannot see 1 and 7 twice. So what we have to do is we have to draw in such a way that they will be overlapped. As A and B are overlap set, if there is common elements, then we call those sets overlapping set. Okay, so if there are common elements, then sorry, we have to write those elements only once in this way. So let's bring A little bit closer, and let's bring B also little bit closer. So you can see 1 and 7 got overlapped. You have to draw on your copy this final figure. Okay, this is the final figure. So remember, while drawing you have to draw two rings A and B and just overlap the rings. Okay, overlap the rings. Overlap the ring of A with the ring of B and write those common elements in this part. Overlapped part. You have to write the common elements, which common elements means those elements which are present on both sides. You have to write common elements on the this overlapped part of both sets 1 and 7. So the remaining element you can see 5 7 remaining elements from the B 4 2 4 6 are the remaining elements. So you can use a rectangle and it is a universal set, isn't it? If you have to write the universal set related to set A and B, then you have to write each and every elements from each and elements inside the rectangle. So that means 1 2 3 4 5 6 7 are the elements inside the rectangle. So as we have to set it, let's see where we have to set. Here we have to set. We have to set on those region where there are these elements. All these elements must be setted. All these elements must be setted. Other than this, you are not allowed to set other elements than these elements 1 2 3 4 5 6. Okay, other elements than 1 2 3 4 5 6 are not setted. So here we don't have other elements. So if there are other elements, then you have to avoid those elements. Just avoid those elements. So this is the Venn diagram for A union B. Now another is intersection. Now there are two sets A and B, and intersection is 1 and 7. Intersection is a set of those elements which are common on both sets. So 1 and 7 are common on both sets. 1 and 7 is present on both sets. So we can circle the common elements also in this way. Let's circle the common elements. 1 is common in both and 7 is common. So 1 and 7 are common elements. That's intersection. Okay, that is intersection. So for that also we need two ring. That's the ring A and ring B. Let's fill the elements of ring A. You can see these are the elements of ring A. 1 3 5 7 are the elements of ring A, and there is a ring B also. And the elements are 1 2 4 6 and 7. So as you have seen the common elements here, 1, you can see the common element 1 and 7. Here also 1 and 7. So these elements must be on overlap part. So let's bring A a little bit closer. Let's bring B a little bit closer. And as they are the common elements, so they are written as a 1, isn't it? Just only once. They are written only once. So this is the intersection part. Let's see where it is set. Let's close with rectangle and write a universal set U, and let's set, yes, this part. Only 1 and 7 will be set, and they are 1 and 7 is set. This is the intersection. So in this way you have to draw the Venn diagram of union and Venn diagram of intersection. So this is also part of revision. This is not actually the course of class 8. Now the new topic which you have to study in class 8 is, this is what we are going to study in class 8. Let us consider these sets. you can see the P set with element 1 3 5 7 11 1 3 5 7 11 Q 2 4 7 9 11 13 is the uh, set Q. Now we have to, what we have to do is list out the element which belongs to set P only. Okay, those elements which are on set P also, unique element of set P. Okay, unique element of set P, so does not belongs to Q. So let's see first what to do. What we have to do is we have to cancel out, the common elements, means those elements which are on both set. So 2 is on both sets, so let's cancel. and and let's cancel out 7 also, and 11 also. Now these are the common elements, and there are few remaining elements on set P, few remaining elements on set Q. Now what we are going to do with those elements, will see later on. Before that, list out the elements which belongs to Q but does not belongs to P also. So we have to keep those elements inside this bracket. Okay, so cancellation is shown in the screen itself. So let me remove whatever I have done here. This shown in the screen automatically. Okay, let's cancel out the common element. As I have already said, you 2 is there, 2 and 2 is cancelled. You can see here 2 and 2 is cancelled. Another is 7 and 7 is cancelled. 7 and 7 is cancelled. Another is 11 and 11 is also cancelled. So there are few elements remaining on set P. There are few elements remaining on set Q. Obviously, isn't it? Now you can see the first here. List out the elements which belongs to P but does not belongs to Q. So we have to only focus on set P. Now as we have cancelled out the common elements, now these elements, three remaining elements in the set P, 3, 5, 3 and 5 are the elements which belongs to P but does not belongs to Q. Okay, which belongs to P but does not belongs to Q. So 3 and 5 are the only elements which belongs to P but does not belongs to Q. So let's write 3 and 5. 3 and 5. Now for here you can see in second question, list out the elements which belongs to Q. That element which belongs to Q but does not belongs to P. That belongs to Q but does not belongs to P. So we have to focus on set Q. Sorry, which belongs to set Q but does not belongs to set P, means these remaining elements 4, 9 and 13 are the elements which belongs to set Q but does not belongs to P. Remaining on the Q are those elements which belongs to Q. Remaining on the P are those elements which belongs to P. 9 and 13. Okay, so remaining elements of set P 3 and 5 are those elements which only belongs to P. Okay, they only lie on P. And 4, 9, 13 are those elements which only lie on Q. So what we call these elements? Difference of set Q, we call it difference of set Q from P. Okay, this is difference of set Q from P. We have subtracted Q from P. You have to understand in that way that we have subtracted Q from P. And what does this mean? Second one, difference of set P from Q. We have subtracted set P from Q. We have subtracted set P from Q. And the remaining will be from set Q only. Okay. Now it is written as, the first one is written as symbolically way. It is P difference Q. Okay. It is the difference sign. Minus, it looks like minus. We say it minus or dash. But it is P difference Q. Now the below one is, it is written as Q difference P. Okay, Q difference, it must be P, not R. Q difference P. Okay, it must be P. We don't have R. Q difference P. So therefore P difference Q is 3 5 and Q difference P is 4 9 13. Now as I have used that word difference, now this is difference of set. We have studied, we have understood difference. If you have understood, then you have understood difference of sets. What is difference of sets? Let's see the definition here. The difference of two sets written as you can see written as A difference B is the set of all elements of A that are not elements of B. Okay, that does not belongs to B. Okay, only those elements of A which does not belongs to B. Here you can see this is the set of those elements of P which does not belongs to Q, isn't it? 3 5 does not belongs to Q. 2 7 11 belongs to Q also, isn't it? So I think you have understood it. So P minus Q in Venn diagram, P minus Q. Okay, I have used that minus word. So by mistake I have done. It's P difference Q 3 5, and let's see in Venn diagram. Now that's the set, a ring for P. It's P, and let's fill the elements of P. You can see we have filled the elements of P. You can see these elements in the corner are the common elements which we have subtracted. You can see which you have cancelled from both the sets. So another is Q. See the Q one. See the elements here in this corner are also the common elements. The common elements are written in the corner part of the ring. So let's bring those rings closer. Here you can see the common elements are overlapped. You can see common element are overlapped here. Now 5 3, where are 5 3? You can see 5 3 are there, right there, isn't it? So let's cover it with and write universal set. 5 3, see 5 3, 5 3 is right here. So we have to set only 5 3. We have to set only that region which includes 5 3. So this is the region which includes 5 3. So that's it, isn't it? This is how you have to draw the Venn diagram of P difference Q. So we have read a new topic, that is difference of sets. It is very easy also. You have seen the process how to find the difference of set. So let's move to another slide. Try this one. The first question. A and B are two sets, and find the elements of the following sets, and in separate diagram you have to separate Venn diagram. So you have to find A union B and draw it in separate Venn diagram. A intersection B in separate Venn diagram. A minus B in separate Venn diagram. B minus A in separate Venn diagram. Okay, let's move forward. Example first. Set of even numbers less than 20. Even number less than 20. Set of multiples of 4 less than 20. Multiple of 4 less than 20. Then represent P difference Q in Venn diagram. Now, first example. Now, set P here. Set P is a set of even numbers less than 20. We are going to list this, but later on we are going to list. First, let's write Q is set of multiples of 4 less than 20. So in both cases, we are not allowed to include 20. Okay, we are not allowed to include 20. So what will be set P in list rooster form? In rooster form, this is the rooster form. In listing form, it will be 2 4 6 8 10 12. All these are all even numbers, and up to 18 or not. We are not allowed to include 20 as it is not defined. 20 is not defined in the set. And Q also multiples of 4, that is 4 8 12 16. We are not allowed to include 20 because it is not defined in the question. So now, as we have listed P and Q properly, P difference Q. Now first we have to write the elements of P. In this way you have to write the elements of P 2 4 6 8 10. Now difference sign, write difference sign, different operator, it is difference operator, and Q. So you have to write in this way, and then what we have to do is you have to cancel the common elements. Okay, it is the process. You have to cancel. Let's see, the first 4 will be cancelled, isn't it? 4 is cancelled. You can see clearly 4 is cancelled. And next, I think it will be cancelled. 8 is cancelled. And 12 will be cancelled. Is there 12? And 16 will be cancelled. So these are the common elements. Common elements are cancelled. As we have to find the p difference q, okay, so we have to focus only on set p. Okay, this is the set p part, and we have to write the remaining elements from set p. So these are the remaining elements from set p. 2, 6, 10, 14 and 18 are the remaining elements. Now this is what p difference q is. Okay, this is the p difference q. Now in Venn diagram, now this is the ring for set p, and you can see the ring for set q also. Now let's fill the element first. Now these here are the common elements. Okay, 16, 12, 4 and 8 are the common elements, and you can see the ring q also. In ring q only 16, you can see it, there is 4, 8, 12 and 16, only these elements. So let's bring the p. As you know, these are the common elements, isn't it? So they must overlap. You can see they are exactly overlapped. They are exactly overlapped. Now where are these elements? So we have to say it in that region where you see these elements. So these elements are here. You can see 2, 6, 10, 14, 18. So let's write rectangle and u. Now we can set here. Okay, this completes our example first. There are a few questions for you, for your self practice. 2 questions. You can see m and n, and if m and n is given, you have to show in Venn diagram. M and n again, and m and n, and you have to show in Venn diagram, and you have to show in shaded region also. In question number 1, it is not written shaded, but you have to shade here also in question number 1 also. So let's move to example 2. You can do this question like example 1 very easily. Okay, I think you are ready for example, next example, or maybe another theory. Example 2. Okay, it's example 2. We have universal set, we have set A, and we have set B also. What we have to do is, we have set C also. Okay, this is interesting question. Now we have to find A union B difference C. Now how many operators are there? There are 2 operators. So you have to set your work twice. Okay, you have to set your work twice. So don't try to do it at once, just do twice in 2 steps. Solution, how? I will show you. You can see in this video right now. First let's write what's given. U is given, A is given, B and C is given. So U is given as 1 to 9, 1 2 3 4 5 6. Each and every element will be included from 1 to 9. A 2 4 6 8 even numbers, and B I think odd numbers, and C is a multiple of 3 less than 10. We can see multiple of 3 less than 10. Okay, you can define in any way possible. Now first task is, it's like simplify. Okay, first we have to do whatever there is inside the bracket. Inside the bracket there is A union B, so you have to find A union B. So for that, let's me show you the process. How many operators you see on your question? As I have already told you, we can see there are 2 operators, isn't it? Union and difference operator. Union and difference operator. The answer is, we can see 2 operators. There are 2 operators, union and difference. So our work must be done in 2 steps. So we will solve this problem in 2 steps. First, we will do whatever there inside the bracket. It is like simplify, isn't it? In arithmetic, what we do, we use first bracket according to the Bodmas rule. So it is the union which we are going to do first. So 1 A union B. We can easily find A union B as we have already learned. So first we are going to write set A. We are going to present the set A, and 2 4 6 is the set A, and union operator. You can see the union operator, and set B. Okay, we are going to present the set B. These are the set B, and according to the definition of union, all the elements from both set will be considered without any repetition. Okay, without any repetition. So we are going to take all the elements from set A and B, but we are not going to repeat the common elements. So let's write those elements. 2, 3, 4, 5, 6, 7, 8, 9 is the union of A and B. So we have union also now. Now we can use this operator, difference operator. How we are going to use? You can see exactly in this way. So first we are going to write A union B. We are going to present A union B. You can see with the color also, and difference sign, difference operator, and C element. C, you can see C is right here, 369. So what we are going to do in difference is we are going to cancel the common elements, as we have already done in previous example. We have to cancel the common elements. You can see 3 is cancelled. You can see on your screen 3 is cancelled, and 6 is cancelled, and 9 is cancelled. Let us cancel 9. So we have to focus on only on first set. Okay, our entire focus will be on first set. So we have to write the remaining elements from first set. You can see 2, 4, 5. These are the remaining elements. 2, 4, 5, 7, and 8 are the remaining elements. So in Venn diagram, we have to present in the Venn diagram. You can see in Venn diagram. So there are 3 sets. So we have to draw 3 rings overlapping. Okay, there is common between the sets. There is common between the sets. There is common between A and B. There is common between. There can be common between B and C also, and C and A also. Okay, there is common between sets. So we have to draw the figure in this way. See, this is the exact way to draw the figure. Now let's name the sets first. This is our set A. This ring is set A ring. This is set B ring, and this is set. The last one is set C ring. So we have 3 rings for set A and B. What we have to do in this case, where there are 3 sets, you have to fill this area first. Okay, this area must be filled first. First, you have to check the elements for this area. This area. For this area, you have to check the element for this area. Is there any element which belongs to all 3 sets? Is there any element which belongs to all 3 sets? 2, you can see only on A. 3 is there, but it is on 2 sets only. You cannot see 3 on A. 4 only on set A. 6 on set A and B, not A and C, not in B. And 8, 9 you can see in B and C, not in A. So there is no elements which is common on all 3 sets. Okay, there is no common element in all 3 sets. So this area will be vacant. This area will be kept empty. Okay, it will be vacant because there is no elements which is common on all 3 sets. There is no element which is common in all 3 sets. So let's keep it vacant. Now next region which we are going to set is this region, simply this region. So we have to find elements common on this region A and B, only on A and B. So let's see A and B, this set A and B. So you can see, can we see any and can we find any element common on A and C? So none of the elements are common on set A and B, as set A is the set of even numbers, set B is the set of odd numbers. So there is no common in set even number and odd number, set of even number and odd number. So this area will also be left vacant. Okay, empty. So that area is also empty, vacant. So we cannot find an element to represent that area. So let's consider this area. We have to fill the element on this area, this part, only this part. So B and C, let's see on set B and C. This is the set B and this is the set C. So you can clearly see 3 and 9 are common on B and C. 3, you can see 3 is common and 9 is also common. So let's write 3 first and 9 also. Okay, 9 also. 3 and 9 are common. Now finally we have to check, are there any elements common on A and C? Are there any elements common on A and C to fill this area? To fill this area A and C. Consider A here, this set, and C this set. Can you find any element common? Yes, we can find 6 is common. You see, 6 is common. 6 is there in A, 6 is there in C also. So we can write 6. Now after completing this task, and now we have to go back to set A. Just focus on set A. 6 is already written from set A. So 6 is already written. So let me circle that one. 6 is already written. So 2, 4 and 8 are not written. So let's write 2, 4 and 8. 2, 4 and 8. Now let's focus on set B only. Which are the elements written? 3 and 9 are written. You can see 3 and 9 are written. So 5 and 7 are not written. Let's write 5 and 7 also. So 5 and 7 are not written. Now let's move to set C. You can see 3 is also written, 6 is also written, 9 is also written. So the remaining area will be left vacant, empty. Okay. Now where are these elements? Where are these elements in Venn diagram? Where are these elements in Venn diagram? 2, 4, 5, 7, 8. Where are 2? Where are 4? Where are 5, 7, 8? Okay. Where are these elements? 2, 4, 5, 7, 8. Where are these elements? In Venn diagram also, let's 2, 4, 5, 7, 8. See, now we have to set only these region, only this region. So how to set? In this way, 2, 4, 5, 7, 8. 2, 4, 5, 7, 8. In this way, you have to say. Okay, I think you have understood. So let's enclose with rectangle and write U. And one thing you have to be careful, there is universal set, isn't it? Are all elements of universal set written? Are all elements written? See, 2 is written, you can clearly see. 3 is also written, 4 is also written, 5 is also written, 6 is also written, 7 is also written, 8 is also written, and 9 is also written. So 1 is not written. So what we have to do is, we have to write 1 outside of the ring in this way. So U means all these elements, isn't it? Inside the rectangle, all these elements must be present inside the rectangle. As these elements are already written, so 1 was there remaining. So we have to write that 1 outside of the ring, and 1 does not belong to any of the set A, B, C. 1 does not belong to any of the set A, B, C. So but it belongs to universal set. So it must be inside the rectangle but outside the ring. Inside the rectangle, outside the ring. So try this for your self practice. Okay, you can do this question exactly like example 2. So let's move to another slide, that is slide number 10. Let us consider these sets. So we are going to learn next operation of set. So we have learned a union, we have learned intersection, and we have learned difference. Now it's time for our next operation. Now we have universal set, and we have set A, we have set B, we have set A and B only. Okay. So what we are going to do is, now let's find difference of U difference A, and let's find U difference B also, as we know how to find the difference, isn't it? So first one, set A, U is written and difference operator is there, and set A is written. Now let's cancel those common elements, as we know how to find the difference, as we have already learned it. So 2 is cancelled, and 4 is also cancelled, and 6 is also cancelled, and 8 is also cancelled. So we have to write those elements which are not cancelled from universal set U, set U. You can see 1, 3, 5, 7, 9 and 10 are those elements which belongs to universal set only, but it does not belongs to A. Okay, these elements are not present on set A, but they are present in universal set U. Now let's write this set as P. Okay, it's so simply a supposition. Okay, now again let's find U minus P. We can easily find U difference P, sorry, not minus. So universal set, a difference operator, and set B. Now let's cancel those common element from both sets. And 7. And 1, 4, 6, 8, 9, and 10 are those elements which only belongs to set U, universal set. Here it is universal set, but does not belongs to set B. Now let's represent it as Q. Okay, set P and set Q. We have two new sets. Again, what we are going to do is, let's find the P union of A and P and B and Q. Let's find the union. We know how to find union, so there is no big deal for it. Okay, we can find this operator U and union operator and P. Okay, we can easily write the elements of P also, but as we have already we have the elements of P here, we have already found it. So the union is, as we know, union is each and every element from set A and P, but without any repetition. So we have written each and every element of set A and P uh, without any repetition. So what is this set? What is this set? Okay, think about it. B union Q, B union operator, and Q. Okay, now let's write inside the curly bracket. So what is this set? This set and this set. What is this set? These two sets, both the sets are universal set, isn't it? It is the set universal set. So what does this means? What does this mean? What does this P and Q mean now? As the union of P and set A is universal set, as the union of set Q and B is also universal set. What does it mean is, we call set P is complement set of A. We call set Q is complement of set. What does complement means? It fulfills the vacant created by A. Okay, set P fulfills that vacant region formed by A. Okay, it takes the few element from universal set and it leaves out the other element. Listen again, listen to me carefully. A takes few elements, like A takes 2, 4, 6, 8, but it does not take the remaining elements. So there is a vacant created by A, isn't it? As it takes the few elements and lifts the other element, it lifts other elements. So that vacant element is taken by set P. That vacant element is taken by set P. So the union of set P and A is universal set. So what does P do? P complements A. Okay, with the help of P, A is fulfilled. Okay, with the help of P, A is fulfilled. A and P combine together to form a universal set. So that set which is required to fulfill and so that the combination will be universal set, that type of set is denoted as, you can see they are denoted as, you can denote in this way also, A prime, AC, or A bar. Okay, here its bar is not shown properly, it's A bar. And here also, after B takes a few elements like 2, 3, 5, 7, there is a vacant is created, isn't it? After 2, okay, 2, 3, 2 is taken, 3 is taken, 5 is taken, and 7 is taken by B. So there are other elements remaining. So it is taken by Q. So Q complements B. Okay, with the help of Q, B is fulfilled. Okay, B and Q combine together and they fulfill and they make a universal set. They form a universal set. So it is denoted by A, B prime, BC, or B bar. Okay, it's bar. Now that is P is equal to A complement, or we have the formula for A complement is U minus A. As we have already done U minus A, you can see here, isn't it? U minus A is equal to P. So P is A complement, isn't it? P is A complement. And the same goes with this also. So there is a name for it, as I have already repeated it twice and thrice and many times, complement. So complement, this is what complement of set is. Okay, as a particular sets, take few elements from a universal set and other elements are remained, isn't it? So those remaining elements are called complement of the particular set. Those remaining elements, after a set takes few elements, it acquires few elements from the universal set and it forms a new set, isn't it? So rest of the elements are remaining. So those remaining elements are the complement of the given set. So if A is that particular set which takes the elements from a universal set and the remaining element will also form a set, and that is complement of set A. Those remaining elements also form a set. Here you can see these are the remaining elements after A has picked few elements, isn't it? These remaining element is also a set and it's the set P, and P complements A, so it is called complement of set. And we can define it is the set of all elements of given set element in the given universal set U that are not in A. Okay, those elements which are not in A but they are on universal set. So that is the complement of set. And one thing you have to remember, complement is always done with universal set. Complement is always done with universal set. Complement is always done with universal set. Their universal set is must to find the complement of any set. Without universal set, you are not you won't be able to find the complement. So let's move to another slide. Example 3, and this example is related with complement of set. So after this example you will completely understood. If there is any doubt, if there is any doubt on your mind regarding a complement of set, then I think this example will clear it out. Now here there are two sets, universal set and A. Here let's write universal set first, and we are going to list the element of universal set but later on. Now let us list the element of universal set. Here 1 and 10 both are included. As you can see the equal to sign here, as this represent 1 is also included and 10 is also included. So let's list it 1 to 10, each and every number from 1 to 10, and we have the set A in a roster form. So to find a complement, you can see a complement can be written as A in this way, A prime, or you can write A bar also, okay, whichever you like easier. Now to find a complement, we know the formula, isn't it? A complement is U minus U difference. Okay, its formula is U difference A. Okay, U difference A. U difference A is the formula. First we have to write U, as we have already written difference operator, and A. Now as there is difference, we can cancel it. Okay, we can cancel the common elements, as we can cancel here 1, as you can cancel 3 also, as you can cancel 5 also, as you can cancel 7 also, as you can cancel 9 also. So we have to focus only on first set, that is this one, and let's write the remaining elements. Remaining elements are 2, 4, 6, 8 and 10 are the remaining elements. Now this is a complement, isn't it? A complement. So with the help of these elements, these are the remaining elements after the set A is formed. Okay, by picking few elements, set A is formed and few elements are remained, and this set is that few element. This set is also, these elements also form new set and they are remaining. In Venn diagram, let's see in Venn diagram, there is a ring and this is a ring A, and its element you can see are 1, 3, 5, 7, 1, 3, 5, 7, 9, and you can see the universal set, and these are the remaining elements. You can see we can go by the color also, isn't it? So the elements which are outside of the ring of A are the complement of A. Okay, very simple way to understand it. Those elements which are outside of the ring of A are the complement of set A. They will be inside the rectangle, okay, universal set, but they will be outside of the ring of A. They are called complement of set A. Okay, will those elements plus elements of A will form universal set. Okay, the elements required to form the universal set, okay, are complement of set. Now let's say those elements 2, 4, 6, 8 and 10 are set it outside of the ring. So example 4, I think you have understood this complement of set. There are 4 questions, and each and every question you have to show in Venn diagrams, in separate Venn diagram. Separately you have to show. There is universal set, and as I think you have You haven't forgotten that for each and every complement, to find the complement of each and every set, you need universal set. Universal set is a must. Okay, let's move to another slide. Example 4. You can see the question. Vowels of English alphabet, and AEIU is set A, IOU is set B. Then we have to find A difference B and complement also. Okay, and we have to show that in Venn diagrams. Let's see the solution. Very easy. There are two operators. There is union operator, you can see, and difference operator. So we have to do in two steps. We have to solve in two steps. Vowels of English alphabet. You can see vowels of English alphabet. We will list that later on. Set A and set B also. Okay, let's list set A, universal set, that is A, E, I, O, U. Vowels of English alphabet are A, E, I, O, U, and other are consonant, isn't it? So our question is this: A difference B complement. First we have to find A difference B, whichever is inside the bracket. Inside the bracket it is difference operator. So first we have to find difference, A difference B, and let's write the element of set A, difference operator, and elements of set B. Now, as we know how to find the difference, we have to cancel those common elements, these elements. Okay. Now we have to focus on set A only, as U is remaining from the set B, but we don't have to do anything with that U. We don't have to consider that U only. Okay, U is also cancelled. Okay, it's mistake here, not O. U is cancelled. O is remaining. Sorry, O is remaining. O is not cancelled. O is remaining. So we don't have to do anything with this O. We have to only focus on the first set. A and E are remaining from the first set. A and simply A and E are remaining. So this is A difference B. Now we have to find the complement of A difference B. Remember, complement of A difference B. Now this is what we have to find, and we know the formula as A complement. A complement is written as U minus A. B complement is written as B complement can be written as U minus B. So we can write A minus B complement as U minus, as we know U will be there. You can see the trend, U will be there definitely, and there will be difference operator. And what will be there inside the bracket? There you will find this one. This element you have to write inside the bracket. A difference B. A difference B. Okay, so you can see the formula here, U difference A minus B. Now again we can do it easily. Universal set, A, I, O, U, and difference operator, and A. Let's cancel A and E. And the remaining you can write IOU is the remaining elements of the set. IO is the remaining elements of the set in Venn diagram. Now there are two sets. So here you can see set A. IU are the common elements. Okay, IU are the common elements. You can see here I is there in set both set. U is also there on both set. So IU are the common element. Here also ring B. This is IU. And let's bring both closer in this way, and I and U must overlap. Okay, I and U got overlapped. So where are these elements? I, O, U. Where are those elements? I, O, U. Let's cover it and write units. And so think about it. I, O, U. Where are those elements? So I, O, U, and right there. See, I, O, U. I, O, U. Here are I, O, U. So we have to set that region where you can see I, O, U. Try these questions. Two questions only. Example 5. Set of whole numbers P, R, and here we have to find there are three operators. See, there is difference operator, there is intersection, and there is complement. Whatever is what is inside the bracket, intersection. So we have to start with intersection, then we have to do complement, then we have to finally we have to do difference operator. There are three operators, so the problem is solved in this example is solved in three steps. Okay, here one operator at a time. Okay, one operator at a time. Set of whole numbers and P and R. So what are the elements of set, universal set? So 0 as whole number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are the set of whole numbers. Now first we have to find P intersection R because we have to start from the bracket. Okay, inside the bracket. So 1 is P intersection R. So let's write the element of P, intersection sign, and element of R. Intersection means common. So let's circle the common elements. 4. Only 4? No. Okay, there is 5 also. Let's circle the common element. 5 is also there. So 4 and 5 are the common elements. We can write 4 and 5. In case of difference, you have to cancel. In case of common, you have to circle. Okay. So now next is complement of this intersection. Complement of this intersection. Now formula is U minus difference P intersection R. Now we have the element of R U also. We have the element of P intersection R also. So union U is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is the universal set. Difference operator and intersection, that is 5, 4 and 5. 4 and 5. Now we can cancel here. 4 is cancelled, 5 is also cancelled. Now remaining we have to focus on first set only. As I have already told you many times, the remaining elements are 0, 1, 2, 3, 6, 7, 8, 9 because 4 and 5 are cancelled. Now finally P difference, P intersection R complement. Okay, P difference, P intersection R complement. In third step, P difference, P intersection R complement. So first elements of P 1, 2, 3, 4, 5 and difference operator and elements of P intersection R complement here, this one red, which is in red color. Now again we have to cancel. We have to cancel the common elements. 1 got cancelled, and again 2 got cancelled, again 3 got cancelled, again no. Okay, we don't have any other common elements. So our focus must be on first set. 4 and 5 is remaining. So our answer will be 4 and 5. Now we have to draw Venn diagram and set only elements 4 and 5. We have to set this element 4 and 5. In Venn diagram, now as there are two sets, so you can see draw this P and Q. Okay, as there are common elements on P and R, we can let's circle this elements. 4 and 5 are common elements, so we have to draw overlapping Venn diagram. Now what is overlapping Venn diagram? So if you are going to draw two Venn diagram and there are common elements, then you have to draw in this way. This is an overlapping Venn diagram. So in this way you have to draw, and this is set R. Now first you have to fill the element on this region. Okay, this region you have to fill the element. Now this region belongs to common elements 4 and 5. This region belongs to common elements 4 and 5. And focus on set P, and after 4 and 5 is taken, 1, 2, 3 is remaining. So let's fill 1, 2, 3. And after 4 and 5 is taken, 6, 7 is remaining. 6 7 here. And as there is universal set, so we have to enclose this with a rectangle. And let's see from the universal set which elements are gone. 1 is gone, 2 is also gone, 3 is also gone, uh, 4 is also gone, 4 is also gone, 5 is also there, 6 is also there, 7 is also there, but you cannot see 8 and 9, isn't it? You cannot see 8 9, and you cannot see 0 also. So let's write 8 9 and 0 outside of the ring, outside of both ring. Okay, so our focus must be on 4 5. Where are 4 5s now? 4 5, see, our focus must be on 4 5. 4 5 is exactly here, you can see 4 5, so we have to set only 4 5. 4 5 is there, see, so let's set 4 5. In this way 4 5 must be set. So this concludes our at another example 5. Now try this 6. There are 3 questions for you to practice. As done in example 5, you have to do exactly as we have done in example 5. Remember, if there are common elements, then you have to draw overlapping Venn diagram. This is the overlapping Venn diagram, and first you have to fill elements here. You have to sort, you have to find those elements which are common on both the sets, and you have to fill here, and here you have to fill the remaining elements, and here also remaining elements after the common elements are filled. Here also you can find 3 operators in the question. There is 2 intersection operator and complement operator also. First we have to start from intersection, as this intersection as it is inside the bracket. Okay, so solution here, universal set, set A, set B, and set C. We have 3 sets already written in Venn diagram. Now show first in Venn diagram. We have to show this in Venn diagram. So okay, we have to do in Venn diagram first. Okay, in Venn diagram. Now, so we have to draw the overlapping diagram in this way, and another set also this way. First we have to fill this region here. This region must be filled. This region belongs to that element which is common on both all the 3 elements. So 1 is there in A and B but not on C. 2 you can say is a common element, and these are set A and B first, B and C. So 4 you cannot see 4, and 6 also only A and B. So there is no element. I think there is 6 is there which is common in all 3. 6 is there which is common in all 3 sets. So you can see C on B also. So let's fill that part first. Now our focus must be on A intersection B here. This region that is common on A and B. Common on A and B. You can clearly see 1 is there. Okay, after 6. Okay, 6 is already written. So you are not allowed to write 6. A, there is only 1. So there is 1. And B and C also. Now let's see here. We have to fill this region. B and C. B and C. Is there any common B and C? B and C? Nothing is common. 6 is common, but we have written 6 already. So nothing other than 6 is common. So we have written 6 already. Now C and A. C and A. First and last. 4 is common. You can see easily. 4 and 6 are common, but 6 is written already. So we have to write only 4. Now our focus must be on set A. Set A. Now 1, 6, 4 are written. 1, 6, 4 are written. 2 is remaining. In B, 1 and 6 are written. In B, 1 and 6 are written. So 3 and 5 must be written. 3 and 5. In C, 4 and 6 are written. So 7 and 8 is not written. So 7 and 8, we have to write 7 in it. 7 in it. So we have completed the plotting of the placing the elements on proper region. Okay, the element which belongs to which region we have written now. So there is universal set inside the bracket, rectangle, not bracket, rectangle, and see. Let's find those elements which are not written inside the rings. So 1 is written, 2 is written, 3 is written, 4 you can find C inside the ring there, 5 is also written, 6 is also written, 7 is also written, 8 is also written I think, and 9 is not written. So 9 will be outside of the ring. 9 will be outside of the rings, all the rings. So 9 is there. So we have drawn the Venn diagram, and first we have drawn the Venn diagram, and then we are going to find this B intersection C. B intersection C. We can easily find B intersection C. Here also B intersection C. Only 6 is the B intersection C. Let's see by doing it by intersection and C. Now only 6 is common, so we can write. You can see 6 is common, so 6 we have to write 6. Now complement of this intersection B intersection C. Second is B intersection C complement. You know the formula U difference. The formula is U difference B intersection C. Okay, whatever there is inside the bracket. See what you see B intersection C. So you have to write B intersection C. So U is 1, 2, 3, 4, 5, 6, 7, 8, 9, and intersection is only 6. Difference operator and intersection is only 6. So 6 will be cancelled, and rest we can write quite easily. 1, 2, 3, 4, 7, 8, 9, leaving 6. 7, 8, 9, leaving 6. And 3 in 3, A intersection, B intersection, C complement. So A, first A, and intersection operator, and B intersection C complement. This is B intersection key complement. Exactly what is done in the previous step. 1, 2, 3, 4, 5, 3, 4. We haven't written 5, isn't it? 6 is cancelled, but 5 is not cancelled. So we have to write 5. There is a mistake, so let's correct it. We have to write 5 here. After 4, there must be 5 also. So here, there must be 5 also. Okay, 5, comma. So you can correct it. So what is the intersection between, see, 2 is common. So you can see 4 is also common. 1 is also common, isn't it? 1 is also common. So if it is missed, then we can do ourselves. And 6 is not common. So let's write 1. 1 is missing. So 1, 2, and 4 is our final elements. So we have to set 1, 2, and 4. 1, 2, and 4 must be shaded. So 1, 2, and 4 must be shaded. Where are 1, 2, and 4? Let's shade that region 1, 2, and 4. So I think 1 is not included in your Venn diagram, which you are going to see right now. But we have to include 1 also. Okay, this is also the part of solution. So 1 is also included. 1, 2, and 4 must be included. 1, 2, and 4 must be included. This is the correct one. So try this 7. So you can do this question easily. And let's move to another slide. So we have to find A union B union C complement. There are three operators, but first we have to draw Venn diagram. Universal set. Set A is the factor of 6, set B is the factor of 8, and set C is the factor. Okay, we have already listed. Factor of 6 means those numbers which divides 6. 1 can divide, 2 can divide, 4 cannot divide, and 5 also cannot divide exactly. Okay, we are talking about those numbers which can divide 6 exactly without leaving any remainder. So 1 can divide, 2 can also divide, 3 and 6 can divide. So 1, 2, 3, and 6 are the factor of 6. Factor of 8, so they are 1, 2, 4, and 8, isn't it? So we have left 3 also. 3 cannot divide 8 exactly, and 5 also we have left. 6 and 7 also we have left because those numbers cannot divide 8 exactly. Factors of 9 means 1, 3, and 9 only. 1, 3, and 9. So 1 can divide, 3 can divide, and 9 can divide. Now in Venn diagram, and 3 overlapping sets we have to draw. 3 overlapping sets in Venn diagram. 3 overlapping sets. Let's see 3 overlapping sets. 1, 2, 3. Let's name them A, B, C, A, and B, and C. 3 overlapping sets. And as I have already told you, while showing in Venn diagram, first is this region. You have to show. You have to find the element for this region. If there is element for this region, then you have to first write here. Okay, there is one. You can see one clearly. One is there in all 3 sets, and none of the element are there on all 3 sets. So one is there. We have to write one. Then you have to move on to this region. Always, okay, follow the order. A and B. A and B. Focus on A and B. Other than 1, 2 is common. So you have to write 2. 1 and 2 are common. 1 is already written. So you have to write 2. And focus on B and C now. This region, B and C. B and C. Which sets are common? None of the sets are common. So A and C now. None of the elements are common. So A and C. First and last. Which element is common? 3 is common. See, other than 1, 3 is common. 1 we have already written. So 3 we have to write. 3. Now our focus will be on set A. In this ring, 1, 2, and 3 is written. So 6 is not written. We have to write 6. 1 and 2 is written. 1 and 2 is written. 4 and 8 is not written. From set B, you can see 4 and 8 is not written. Let's write 4 and 8 there. And from C, 1 and 3 is written. 9 is not written. So let's write 9 there. Okay. Now let's close this with a rectangle. And let's write U. And okay, let's find the element from universal set which is not inside the ring. 1 is already there, 2 is there, 3 is there, 4 is there, 5 is not there, isn't it? You cannot see 5 inside the ring. So let's write 5 first. And 6 is there, 7 is the another element which is not inside the ring. So let's write 7. 8 is there, 9 is there, and 10 is the another element which is not inside the ring. So 10 is there. So now we have drawn the Venn diagram. Now we have to find the elements for A union B union C complement. First we have to do inside the bracket, that is A union B, B union C, sorry, and B is, you can see, union and C. So as we know from the definition of union, that all elements from both sets will be written without any repetition in this way. And now let's do a union with A. Now you can start from A union B, okay, because there is you cannot see another bracket. You can start with A union B, and you can join, you can add C later on, or you can do with A and C and add B later on. Okay, it doesn't matter. Okay, we have started from B union C and we have added A later on. So let's write A and so let's write all the elements without any repetition. That is what union is. Now complement. Now it's time for complement. A union B union C complement. A union B union C complement. And you know the formula, U difference, always U difference, and this set without complement. This set without complement. See what is there? A union B union C. So let's write universal set, difference operator, and 1, 2, 3, 4. Now let's cancel those elements which are common in both, where 1 is common in both, 2 is common in both, 3 is common in both, 4 is common, 5 no 5 6 8 is common, not 7, 9 is common, not 10. Okay, okay, let's write those elements 3 7 and 10. Where are 5 7 and 10? Sorry, 5 7 and 10, 5 7 and 10 are here, so you can see with a pink color 5 7 and 10. So we have to set the region outside of the ring. Okay, this entire region outside of the ring is a complement region. Now let's zoom it, 5 7 and 10, and let's zoom in Venn diagram also. Yes, 5 7 and 10. Let's set 5 7 and 10. Now this is our answer. Okay, try these 7. There are 2 questions for you to practice. You can see the question, you can do these questions easily. Like example 7, you can practice it, you can pause the video and you can resume, or you can resume. Let's resume it. Example 8. There are many examples. Okay, we are now exactly in the halfway of the video. There is universal set, there is set A, there is set B also. What we are going to do is then prove that this is complement. Okay, it's you cannot see it quite clearly, so let me clear it, make it clear. There is complement. This is complement, only A complement right here. This is B complement. Okay, A intersection, A complement intersection B complement. Solution we have to do from both sides, left hand side and right hand side. Universal set, set A and set B. First we have to do left hand side. This is our question. This is our question, and left hand side. In left hand side, what we have to do is we have to first find A complement. Okay, only this A complement. So A complement AC, it is written, and formula is U minus U difference A. It is U difference A. So this is universal set, difference operator and A operator. Now you can see the difference operator and A is not operator, A set. So let's cancel. 1, 3 and 4 will be cancelled, and remaining is 2, 5 and 6. This is the difference of universal set and set A. So 2, 5 and 6. In the same way we have to find B complement also. It won't take time. U difference B, this is the U, isn't it? This is the set U and difference operator and A. B, sorry, B. Now let's, 3 is cancelled, 4 is cancelled, 5 is cancelled and 6 is also cancelled. Now remaining is 1 and 2 only. 1 and 2. So we have to find the intersection of these two sets. These two sets. Now finally, A complement intersection B complement. Okay, this is bar is, it's quite not clearly seen. So first A complement, element of A complement, that is 2, 5, 6, and intersection operator and 1 and 2. Is there any common? Yes, definitely 2 is common. 2 is common, isn't it? So let's circle 2. 2 is common. 2 is common. So let's write 2. So our left hand side is 2. From right hand side also we have to find 2. After that it will be proved. So right hand side, first we have to find A union B, as it is inside this. So A union B, set A union operator and set B. Now all elements of both sets without any repetition is what union is. Now we have to find the complement of this union, A union B complement, and you know the formula, U difference A union B. A union B. Okay, now let's start this element of set U first, difference operator and element of A union B. So let's cancel common elements from both sets, and 5. We have to focus, and 6 also. We have to focus on this set, only 2 is remaining. So let's try 2. So you can see left hand side and right hand side are equal, isn't it? So we have proved. Therefore, left hand side is equal to right hand side. So there is one question for you. Try these 8. Same question, same elements, but in a different way. So this is complement. So if it isn't seen clearly, then it is a complement. Okay, this is the second. This is the first one here. I here it is I. This proof which you can see are De Morgan's law. You will study this in higher classes in 11. This law is called De Morgan's law. Okay, let's move to another slide. Venn diagram and various shaded region. This you have to notice this. You have to observe this carefully, as it will be asked as a very short question in your exam. Now, if this region of the set is shaded, this region you can see black region, then its set notation is A intersection B. Okay, its set notation is A intersection B. Now, if this part is shaded, see the entire A and B ring are shaded. It is A union B. A union B. This the set notation is A union B. If it is shaded outside of the ring, not including set A and B, then it is set A and B complement. Set A union B complement. Set A union B complement. If you see this type of Venn diagram, then the set notation for it is A union B complement. If we see in this way, only so some part of A is shaded, common part is not shaded. So this is for A difference B. Okay, A difference B. A difference B. And if you see here, only the some part of B is shaded. Not common part is also not shaded. Here you can see by leaving the common part shaded, it is B difference A. B difference A. Now you can see here, uh, every every region is shaded except intersection. Intersection is left, so it will be A intersection B complement. It will be A intersection B complement. It is A intersection B complement. So you have to observe this very carefully. Okay, let's move to another slide. Some more Venn diagram. You can see. Continue. It is Venn diagram and various shaded region. Continue. If you see this kind of Venn diagram where set A is not shaded and all other part of universal set is shaded except A, that means it is A complement. Okay, and in 3 set, this is the Venn diagram 3 set, and on this part is shaded. If you see this part, only this part shaded, then it is set notation of now its set notation is A intersection B intersection and C. And another, now if you see all the ring are shaded, then it is its set notation is P union Q union R. Now try this. Try to draw the Venn diagram for these given set notations. Now we are moving towards the next part of this video, that is word problems on sets. That means word problem, and we are going to do this with the help of Venn diagram, using Venn diagram. So operation of sets using Venn diagram is first presented by the mathematician John Venn. So with the name, with his name, Venn diagram is we call it Venn diagram because it is first presented by the mathematician John Venn in 20th century. So Venn diagram is named after him. Observe the given Venn diagram and answer the following questions. Set A, overlapping set B. So A and B are overlapping set. There is something common between them. This is a rectangle which is universal set. Now there is element 2, and you can see the color, the different color, blue color 468, and pink 357, and green 1 and 9. List the element of set A. Now what will be the element of set A? The element of set A, you don't have to get confused. Element of set will be those elements which are inside the ring of set A. Inside the ring of set A. Now list the element of B difference A. Okay, B difference A means those elements which are only on B, not in A. That means 2 is the element which is also in A. Okay, 2 is also in A, so 2 is not included. 3, 7 and 5 are the elements which are only on B, not in A. List the element of set A intersection B, that is common element 2. Now let's the element of A union B, means we have to write each and every element from both the ring of A and B, but without any repetition. We have to write each and every element of both ring A and B, both sets A and B, without any repetition. Element of A union B complement. Now A union B complement means outside of A union B. A union B is from this set A and B. Okay, A and B. Set A and B is set A and B is A union B, and outside it, that means 1 and 9 are the complement of A union B. And set of element universal set means entire rectangle. Whatever element is there inside the rectangle. So the first answer is inside this ring A, that is 2, 4, 6, 8. Inside the ring A, each and every element inside the ring A, ring of A. B difference A 3, 5, 7. Intersection 2. And union all these elements from here and here, and complement 1 and 9 means outside the ring of A and B. Okay, outside the ring of A and B, whatever element is there outside the ring of A and B, that is A union B complement. And universal set each and every element from inside the rectangle, that is universal set. This is the studying of Venn diagram and answering the question. Okay, now see how many elements are there in given set. That means in set A, how many elements are there? There are 4 elements, isn't it? There are 4 elements. So same goes with this set also. How many elements are there in set B given set? That is B difference A. There are 3 elements, isn't it? There are 3 elements. You can easily say there are 3 elements because you can easily count it. They are countable set. So there are only one element inside the set A intersection B. There is only one element. And here 1, 2, 3, 4, 5, 6 in the set 1, 2, 3, 4, 5, 6, 7 elements are there. There are 7 elements. Now here how many elements are there? 2. There are 2 elements. In this set there are 2 elements. Here how many elements are there? There are 9 elements. Given universal set there are 9 elements. So you can count the number of elements inside the set. So what shall we call it? Now our conclusion is, what shall we call it? Okay, the number of elements present in a set is called cardinality of the sets. Okay, it is a cardinality of set. Now it is written, cardinality is written as cardinal number cardinal number and cardinality. Okay, it's the cardinal number of set A. Now here cardinal number of set A is 4. Cardinal number of set here in this case is 3. It's 1 cardinal number. Okay, it's written as n, small n, you can see outside the bracket of given set. Now in the same way, in the first set we write the cardinal number of set A is 4. For second, its cardinal number of set B difference A is 3. Cardinal number for set A intersection B is 1. Cardinal number of set A union B is 7. Cardinal number of set A union B complement is 2. Cardinal number of set universal set is 9. That means there are 9 elements inside the universal set. So let's move to another slide. Here, if you have missed, okay, I think I moved it quickly. So here it is. I think hope you understood it. Something basic. It is something basic only. So let's move to another slide. The only concept. Okay, now we have to develop the only concept. What is only concept? Now let us observe the given Venn diagram, and you can see the Venn diagram right here. Now elements are filled, everything is done and dusted in the Venn diagram. Now A difference B is 4, 6, 8. Okay. Now the cardinal number of difference set is 3. There are 3 elements, which belongs to set A but does not belongs to set B. So how many elements are there in set A which belongs to set A only? That means only A. There is 2 also, but 2 belongs to set B. Okay, so that means only 4, 6 and 8 belongs to set A. 4, 6 and 8. See, now if we take this part out here in this way, you can see 4, 6 and 8 are the elements which belong to set A only. There are 3 elements. Now this is the only concept. Okay, this is the only concept. Means what we can say is we can represent and represent as n naught. This means only. No means only A. So only A. There are 3 elements which belongs to set A only. There are 3 elements which belongs to set B only, but this element belongs to both the sets. So difference of set is also called only. Okay, only concept. Now try this 10. You can do this question from the help of this Venn diagram. There are various questions you can answer from the Venn diagram. I think you understood what does only means. So whatever value you get from the difference is the only. Okay, that's the only A, only B, only C. Understanding the different region on Venn diagram. Okay, for of 2 sets. We are not going to do more than 2 sets. Now this is the rectangle, is universal set, and you can see 2 sets, A and B set. Which part of the Venn diagram is for which set notation we will see in a single Venn diagram. Now you see the red in color. This part of the Venn diagram is for, now let's take that out. A intersection B. So intersection is first. Intersection is this. Okay, this part is intersection part. This part of the Venn diagram is intersection part. Now this green part, you can see the green part. Let's take that green part out. Now this green part of the Venn diagram is only A. Okay, as we have already done in previous slide, isn't it? Only A. This part is only A. It looks like a partial moon, isn't it? Partial moon. Now this blue part is only B. This is only B. This blue part is only B. Now there is one more part remaining in orange color, you can see. Let's take that part also out. Now this part is called A union B complement. Now there are 1, 2, 3, 4 parts in a single Venn diagram. Inside a rectangle there are 4 parts. Okay, there are 4 parts. Now if we take all these parts like this here, then if we take that out, now this is A union B. This is A union B. Now from here, from these parts, this small pieces of figure, if we join together, then we will get a formula. Okay, now see the plus sign where it is. Here it is the plus sign. If we add this only a plus a intersection b plus, there also plus, if we take only this part and this part here, if we take these two parts, then we are going to get, you can see by the arrow, these two together will form set A. Okay, this n naught A plus n A intersection B will form the set A, will form the set A, that is NA, that is NA. Now if we add another this set, that is NA, now you have to write in your copy, we have one formula, that is n naught A plus n naught A and only A plus n A intersection B is equal to NA. That is our first formula. Okay, I'll show the formula in this next slide, but you also have to note it down that the first formula is NA, cardinal number of A is equal to only A, cardinal number of only A plus cardinal number of A intersection B. That is our first formula. Now what we are going to do, we are going to add one more set here. Okay, one more, there are three portion. Now n not A, only A intersection and only B. On these three, plus there, and if we add another also, four parts, this one, this complement also, so plus there also, this one is adding with this one. Okay, which gives us universal set. If we all combine all these parts of the Venn diagram, these small parts, then we are going to get a proud rectangle. Okay, it's a bigger rectangle, it's a proud rectangle. Okay, that is our second formula. So what is our second formula? Only A plus A intersection B plus only B plus N, A union B complement is equal to NU, is our second formula. Now next one is, if we add this and this, that means here these two, N A union B and N A union B complement, then we are going to get another formula, that is proud universal set NU. Okay, so formula for NU, there are one more formula for NU, that is N A union B plus N A union B complement is the formula for NU. Now here also, if you see here in this figure, concentrate here, and this is the green part is only A, red part is A intersection B, blue part is only B. If we add all these three parts, simply three parts, then what we are going to get is, we are going to get N A union B. Okay, we are going to get, so how many formula are there? There are four formula, and all this formula will be summarized in next slide. So before that, let me say you once again, NA is equal to only A plus NA intersection B. This is our first formula. And if we add all these four parts, 1, 2, 3, 4 part, we are going to get this formula NU. And if we are going to get these two, it is NU again, that is third. And this is our fourth formula. And only A plus intersection plus only B is equal to, also it is N union B. So you can write this, you can pause the video and you can write. And let's move to another slide where you can see the formula. These are the four formula which we discussed in the previous slide. So you can note this four formula, note this formula on your copy, and but throughout the exercise you are going to see this formula on a formula wall. So let's do exercise related to these formulas. By applying these formulas, we are going to do a few examples. Now the first example, using this formula or marble problem on sets. The first one, and but it is overall the example. First, as I have promised, you are going to see all these formula on formula wall throughout the video from onwards. Okay. Example 9, but first question related to this formula. See the question, it is a marble problem, it's a word problem. There are 75 students in a class and 50 like visiting. Visiting means visiting some places or visiting museums or visiting some scenic place. Okay, now and 50 like picnic, they want to visit a single place and where they will sing, dance, or they eat and they enjoy with their friends. So 50 likes visiting, 50 like picnic, and each student like at least one activity. Now this one I'm going to explain you later on. Using Venn diagram, find the number of students who like both. Both means there may be some student who may have common interest, like they like to visit and they like to picnic with friends also, or family with family also. So there may be common student. Both means common. Okay, common on both events, visiting event and picnic event. We have two events, visiting and picnic, and there may be some people. There may be some students who like both the activity. Okay, so that is the common one. Number of students who like both. We have to find the number of students who like both. So solution. Now these numbers has a special. Uh, they are mentioned as a special. Now see 75 students. Total student, that is total student in a school. And this 50 like visiting. Now number of student who like visiting, that is 50. Number of student who like picnic, I can see, right, student who like picnic, it is 50. Now these numbers are for some activity, isn't it? Now this is for the entire this is for entire set 75, where our solution is based on 75 students. Among them, some like visiting, some like picnic, and some like both activity. So so our calculation is based on 75, but among them 50 like visiting and 50 like picnic. So the total here is 100, but as I've already told you, we are doing our calculation on 75 students. So there are few students which we can easily guess that there are few students who are common, who has common interest like visiting and picnic both. So let us denote that NV is the number of students who like visiting, and NP is the number of students who like picnic. Now let's draw the Venn diagram. This is for visiting. We have to draw overlapping diagram in this way. Picnic. Okay. Now visiting and picnic, and a rectangle and universal set. So after this, first thing we have to do is we have to fill this place. Okay. This region in the Venn diagram. This region in the Venn diagram must be filled at first. If there is a value, then just put the value. If you don't have the value, if you don't get the value from the question, then just write x. Now do we have value here? No, we don't have, because if you read the last line, find the number of students who like both. Now both is this, common region is this, as I have already told you. Both means common. Okay, common interest like visiting and picnic, both common interest. So common is written here, so we don't have the common value. We are going to write x there. Here it's v. This region is only v region. Okay, this region is only v. That means the number of student who like only visiting, they don't have any interest on picnic. Okay, they don't have any interest on picnic, so only visiting, that's here. So we have to write 50 minus x. So we have to remove the common student, we have to subtract the common student. Here we have to subtract the number of students who like visiting, so it must be 50 minus x. Now this x is the number of students who like both picnic and visiting. So in this region, to write the value in this region, what we have to do is we have to subtract that number of students whose interest is common. Okay, those who have common interest, we have to subtract the number of students those who have common interest. So we have to do same on both sides. So what will be outside here? Okay, so we will talk about that from Venn diagram. Nu equal to 75, and only v is 50 minus x, and intersection of means common, that is x. Here only p is, say, let's say, we have supposed, so that's why we write say. So only p 50 minus x, Now focus now in this rectangle. Each student at least one activity means minimum of one activity. So among these 75 students, there are no any student who reject both the activities like picnic and visiting. So there are students who either they like visiting or picnic. So we don't find any student who doesn't have interest on both activity like visiting and picnic. So that's why if you see anywhere in your question in class 8 9 or 10, if you see at least one activity, that means there is no complement, there is no complement. So value of complement is 0. Okay, it's empty, its complement set is totally empty. None of the students uh, is of that type who reject both the activity. So wherever there is at least, okay, remember this thing, if there is at least, then that means complement is 0, complement is 0. So nothing you can place outside of these rings, nothing you can write outside of this ring. We have we have the formula. That's the second formula. Let's substitute the value and not v. You can take the value from here, 50 minus x, and intersection, that is x, you can take from here, and only p, 50 minus x again, and uh, complement 0, and total, that is 75. Now we can cancel x and x. Okay. X and x, so 50 and 50, it's 100, 100 minus x equal to 75. So interchanging the side of x and 75, that is 25 equal to x. Now see, 25 is the number of students who like both the activity picnic and visiting. Okay, they have interest on both, uh, going out for picnic and just for visiting also. Number of students who like both is 25. Now try this 11. There are two questions. You can see the question here. There are two questions, and in both questions there is at least. So that means complement is 0. At least complement is 0. Rest is same. So you can do this question, these two questions, and you can move to another example. That is example 10. Okay, shall we? Okay, we can move. Okay, formula 1 as usual. Example 10. You can see the question on your screen. In a survey of 200 game lovers, means there are people who like certain games. Okay, 200 game lovers. It was found that 120 like football and 95 like cricket. That means 120 like football means they like to watch, or you can say they are the fan of football. They like to follow football, or they play football. And 95 like cricket means they follow cricket, or they like to play cricket, or they are the fan of cricket. Okay, they watch cricket. So 25 are those who are not interested on both these sports. Maybe they like hockey. Okay, 25 maybe the number of people, students or people in a survey who like hockey, or they may like athletic, or so they may like car racing, or their motor gp or formula 1, or they may like wrestling. They don't like this is a real sports, they like some narrated sports like wrestling, isn't it? So some frictional sport like wrestling can be any sports, like they like a video game also. Okay, indoor sports, outdoor sports. So 25 is the number that is against the given condition. Okay? Football and cricket is our given event, and 25 are the number of people who are against the event, they are out of the event. Okay, you are talking about the football and cricket, and somebody other comes there and says that, oh, last night I saw the hockey match between Germany and India. Okay, so that means that person is out of the circle. That person is out of the circle. He doesn't have any interest in football and cricket, but he has interest in other sport. So that this 25 is against the event. It's the rejection. So let's 25, that is total number of people in the survey, and you can see 120. 120 is the number of people who like football, and 95 is the number of people who like 95 is the number of people who like cricket, and 25 also will like who did not like both game. 25 is the number of people who did not like both game. He may like third game. Okay, also he is also 25. That number of 25 is also the sports lover, game lover, but out of the cricket and football circle, So Venn diagram, first let's denote these football and cricket in a set form. So you can see NF and NC is the number of people who like football and cricket respectively. So we can draw a Venn diagram, overlapping Venn diagram. This is of football. Overlapping Venn diagram, we have to draw overlapping Venn diagram, and another circle will overlap the given circle. Now this is cricket, rectangle, and universal set. It's the universal set. Rectangle is for universal set. Now first, as I have already told you, first we have to try to fill this part, this region. It is a common region, so we don't find the number of people who are interested on both cricket and football. So who like both games, we have to find. See, you can see, find the number of people who like both games. That means this value is unknown, so we have to write x. Now here f, it must be football is 120, so 120 minus x. Cricket is 95, that is 95 minus x. Now this x is the number of people who are interested on both sports, football and cricket, isn't it? We in our lifetime follow more than one sport, isn't it? Not only two. We can follow more than, we may be interested in more than 3, 4, 5, 6, 7 also. In our lifetime we may play 2 or 3 sports also. Okay, we may be good on playing 2 or 3 sports also, genuinely. So this x is a common among football and cricket, the common number of people among who like football and cricket. So 25, we have our next number, that is 25 is outside of the circle, as I have already told. They are also game lover. These 25 people are also game lover, but they don't love football and cricket. They don't like football and cricket, so they are outside of the circle. So they must be kept outside of the circle because they don't belong to the circle, neither of football, neither of cricket. From Venn diagram, let's copy out those information. Nu for universal set, uh, this n not f 120 minus x, and complement intersection, and say we have supposed this one, and now only cricket is 95 minus x. This reason is for only, as you, if you have forgotten, then you can go back, you can rewind your video and see which region is assigned for which set notation. Okay, this region is assigned for only cricket set notation, and so this region is assigned for only football set notation. So here this region is the region where people who are only interested on football are kept. Okay, they are the people. So we have to subtract the common element from here. So if we subtract the common element from the circle of f, then we get this particular region where right now I am working on. So complement is 25. So we have the formula. Okay, you can see the formula. The second one, mostly we use this second formula. Now let's fill intersection, that is x. Only C, only cricket, 95 minus x. Let me make you clear this thing once again. 120 like football means In this 120, there are some people who may like cricket also. Okay, in this 120 football loving people, number of people who like football, there are few people who may like cricket also. So we have to subtract that common element from this 120 so that we can get the only element. Okay, so only 120, only only football, so 120 minus x, only cricket 95 minus x. So this x is the common element which we have subtracted. This x is the number which like football also. Okay, not cricket, football and cricket both. So this ring is a complete cricket ring, and in this ring if we subtract the common ring, then we get the only cricket part. Okay, this is the only cricket part, so which is equal to 200. So now we can subtract x and x. So 120, 95 and 25, it is 240, and minus x, let's change the position of x and 200. So it is 40. So therefore, number of people who like both the sports, football and cricket, is 40. Okay, 40 people like both the sports. So this completes our solution. 4 marks you will get if you do in this way. Now there is only one question for you to practice. Practice this question. Okay, do this question yourself. Try to do this question. Example 10. It is like example 10. Here you can see the person who does not like volleyball and football is also given, that is 5. These 5 people does not like football and volleyball and football. So they are complement part. Okay, this part complement. They belongs to complement region. They will be outside of the circle of volleyball and football. They will be outside of the circle of volleyball and football. Okay, hope you understood the question. You will do it, I know. So let's move to another example. Formula 1, then our example will start. Example 11. You will see the question. So we have to do by finding the Venn diagram, by making the Venn diagram solution. Now 100, first we have to focus on 100. What is 100? 100 is the number of student, total number of student. So let's write total number of student equal to 100. Now next our focus will be, you will see the rectangle. Yes, 60 passed in mathematics. Now this 60 is the number of student who passed in mathematics. So our next focus will be in 20. 20 passed in both subjects. Okay, so 50, sorry, 50 passed in science. Okay, so let's write 50 passed in science. So mathematics and science are our events. Main events are mathematics and science. So if they are passed, then it will be intersection. If they fail, it will be complement. It's as simple as it is. Okay. Now if they passed, it will be intersection. Now here this 20 is the number of students who passed in both subjects. Means they are associated with these two subjects, mathematics and science. Those who are not associated with passing of mathematics and science, those who are not related in passing mathematics and science, they are complement. They are failed students. So let NM and NS represent the number of students who passed in mathematics and science respectively. Now let's draw the Venn diagram. This ring is for mathematics, and another overlapping ring, that is science ring, and rectangle is there, and the universal set. Now first, as I have already told, we have to fill this part. Do we have for any value for this part? Yes, we have 20 is this. Both, it's a common, isn't it? Passed in both subject, that means common in mathematics and science. So let's write 20 there. Now here it is, the ring, entire ring is 60, but what we have to find is only mathematics. Only mathematics, that is 40. Only science, we have to subtract the common value, subtract the common value, that is 20 is the common value, that is 30. 30 is only science. This is the number of students who passed in only science. Okay, out of 50, only science. The rest of the 20 passed in mathematics also. Now x is outside because we don't have the value, we don't have the number here. So from Venn diagram, let's copy the information, copy out the information, that is universal set is equal to 100, and only passed in mathematics, that is 40, intersection is 20, isn't it? And only in science, that is 30, and complement. It failed in both subjects, that means complement. They are not related with passing up to subject mathematics and science. They are out of the circle. So complement is safe. Now let's try the formula, that is formula number 2. Okay, our formula number 2, we have to use this formula number 2. You can see the formula on your screen. Now let's put the value. Only m is 40, intersection is 20, only s is 30, and complement is x, which is equal to 100. So the number, if we add 40, 20 and 30, 40, 20 and 30, we get 90. 90 plus x is equal to 100. So 90 can go to right hand side and subtract with 100, and we get value of x as 10. X is equal to 10. So this is the number of students who failed in both subjects. Okay, so it is outside of the circle. So there is one question for you to practice. You can do yourself. Another try is only one question. With the help of this example, you can do this question. Okay, the question which you are right now seeing on your screen. Volleyball, and 17 like volleyball, 15 like basketball, and 10 like both subjects. We have to find the number of students who did not like this volleyball and basketball, these two games, who like any third game. Okay, volleyball, basketball, then third game, or any other game. Any game. Any game means these two games. Okay, out of these two games, not any game which does not like a sport. It does not mean like that. Maybe cricket, maybe football, but there is the number of students who like volleyball and basketball is bigger number. Example 12. First formula 1. Now solution, you can see the question, and I think you have read it and you have understood it also. So let's start our solution. 450 is the total number of students in a school. 450 is the total number of students in a school, and 250 is the number of students who like orange, and 280 are the number of students who like apple. 280 like apple. So let's write like apple equal to 280. 40 dislike both means they are out of the circle. Okay, dislike both. We're talking about pass, and if suddenly fail comes, then that is outside of the circle. If we were talking about like and dislike comes, that is outside of the circle. Okay, so did not like both fruit means it is outside of the circle. That is complement. Outside of the circle means complement. 40 didn't like both fruits, that means they are outside of the circle. So let's write this language. Let NO and NA denote number of students who like orange and apple respectively. Now let's draw the Venn diagram, and O. Okay, this is for orange. An overlapping circle, a ring will be drawn in this way, and it is written A. Orange and apple, and rectangle for universal set and U. So as I have already told you many times that first we have to try to fill this part, isn't it? Here, do we have the value? No, we don't have, because we don't have value. You can see here the none of the information is related to both, isn't it? Here it's written both, but did not like both. It's not common. Okay, common means liking these two fruits. Okay, orange and apple. This reason is the common reason for those people who like both orange and apple. Orange and apple. So here we don't have the values, so it's x. Here you know how to write it. It is 250 minus x. Here you know how to write it. It's 280 minus x, and we have this number. This number is outside of the ring, isn't it? Did not like means outside of the ring. It's outside of the ring scenario. Now let's copy the information from Venn diagram. Nu equal to 450, and N naught O equal to 250 minus x, and intersection is equal to x. So let's say, and it's not only O, it's A. Okay, it's apple here. So the complement is 40. From okay, we have the formula. We are going to use the formula number second. N naught O plus O intersection A plus N naught A plus O union A complement equal to universal set. Now we have to 250 minus x plus x, it is x. We can cancel this x right away, and it's 280 minus x plus 40. Okay, plus 40 is complement from here, and which is equal to 450. Okay, we can add these values 250, 280 and 40, and we get 570 minus x equal to 450. We can interchange the position of x and 450, sides of x and 450. 450 equal to x. Now on subtraction we get x is equal to 120. So this is the number of a student who like both fruits, orange and apple. Both fruits means orange and apple. But what we have to find? Only orange. So you know this is the only orange, isn't it? This is only orange. Here we have only orange. So we have to find the value of only orange. So again, now we can use that formula, N naught O equal to, we can write that one. See, this is a red box, N naught O equal to 50 minus x, which is 130. 130. So 130 is the number of students who like only orange. So 130 is the number of students. Previously, our solution used to end here, right here, but we have to do one more step in this question. So this type of question are very, very important from examination point of view. Now there is one question for you to practice yourself. Same sort of question, okay, exactly same sort of question. Apple only we have to find. Apple only. Now let's move to another slide. Now we are nearing the end. So example 13. You can see the question on your screen. It is based on percentage. Okay, now there is interesting thing about percentage. 55% like apple, 70% like 70% student like banana, 30% like both, that is intersection, and then what percent did not like, what percent of the student like apple only. We have to find it. Find what percent of the student do not like any of the fruit. First we have to find apple only, then by drawing Venn diagram we will definitely find do not like, means it is complement, isn't it? We know that very well up to now. So solution, now the information you can see in a box, 55 like apple. So it is a number of percentage of student, it's not a number, it's a percentage of student who like apple. And another you can see 70% like banana, it's the percentage of student who like banana. Percentage of student who like banana, 70%. There is another value also, 30% like both, means that is the percentage of 30% like both, that is the percentage of student who like both fruits, who love both fruits, who enjoy both fruits. So percentage of student who like both fruits is 30%. Now information is completed. Now total student is equal to 100%. In the case of percentage, if the question is given in the percentage, then our universal set, that is total, will be 100. Remember this thing, in case of percentage, total is always 100. Now, so NA and NB, apple and banana, NA and B, apple and banana, denotes the percentage of student who like apple and banana respectively. So NA does not represent the number, here it represents the percentage. Okay. Now let's draw a Venn diagram. Apple and overlapping Venn diagram, overlapping ring for banana, and rectangle, U. Okay. So first we should try to fill this part. Both, is there both? Yes, like both. Okay, there is like, and also here see like and both. So it is intersection 30%. Now A is entire A ring is 55, but we have to subtract it, so it will be 25%. And entire B ring is 70%, so we have to subtract 70 minus 30%, that is 40%. So did not like, do not like, or did not like both fruit, that is out of the ring. Out of the ring we have X quotient. So let's copy the information we acquired from a Venn diagram. Total, as I have already told you, it is 100%. Only apple for 25%. Intersection of apple and banana, it is 30%. Only banana, only banana. Okay, you may see another thing. You may say it's a technical mistake. Uh, Now you can see only banana, it's 40%, and complement of both apple and banana, it is X%, that is C. Now we have our formula, that is formula 2. You can see the formula. Same formula we are using again and again. 3 more examples, I think, to conclude this video. So let's substitute the value of N not A. Only A is 25. Intersection is 30. And only B is 40. Now we are going to write only B, and intersection is X%. Complement is X%, which is equal to 100%. Equal to 100%. Now we can add these three: 25%, 30%, and 40%, and so we can get it is like 100% minus. We can take those values to another side. You can do it in your own way. So the value will be 100% minus 95%, that is 5%. So 5% of the student do not like any food. But we have to find apple only. So we have already found apple only. You can see 25 is the apple only. So you can see the box. This is the apple only box here. So we can write in language a percentage of a student who like apple only is 25%, and percent of student who did not like any fruit is 5%. So this concludes our solution. So do we have exercise or not? Yes, we have. That is example. That is try this 15, and how many questions? Only one question. So you can do this question with the help of example 13. There is failed in mathematics. 45 students failed in. We are talking about student who failed. Okay. If suddenly past student comes, then it will be complement. It will be outside of the circle. What we are talking about? We are talking about failed student. If suddenly past students appear, then he or she will be outside of the circle. That is complement. So let's move to another slide. Or another slide will give us another example. Example 14. So let's see the question. Now this question is also related with percentage, but we have the total number of students. Okay. Now this case here and the case on example 13 is little bit different. Here we are going to deal with numbers because we have the total number, so we can find the number of like 60%. We can convert that 60% into a genuine number. Okay, now let's start the solution here. A slight difference is there, not much a difference. So 150 student is the total number of students. So let's write total number of students. Now 60% passed in mathematics. That 60% must be converted into number. Okay, this 60% must be converted into number. And how to convert it into number? Let's see. Passed in mathematics is equal to 60%. Okay. Now, okay, let's write in percent right now. And 50% passed in science. So passed in science is equal to 50%. 40% failed. We are talking about pass, and certainly failed comes, then it is complement. It is outside of the circle. It's outside of the ring. 40% failed in both subjects. That means fail in both subjects is 40%. Now what we have to do is we have to convert this 60% into number, and how we are going to do is you can see 60 by 100 into 150 into total. So we can cancel a 0 here and 0 here and 0 here and 0 here. So it is 6 into 15. It is 6 into 15, that is 90. Here also same process we are going to apply. Here also 50 upon 100 into 150. Total is 150. So here also we can cancel 0 and 0 and 0 and 0. So 5 into 50, that is 75. So 40 also we can convert into number. Cancel 0 and 0, it is 60. So we have number. Now this question is like any other question. This for mathematics. It is for science and rectangle and universal set. Now first we have to try to fill this part. Do we have any value for it? No, we don't have. Okay, see. So pass fail means we have to suppose it. Now m is 90, 90 minus x. S is 75 and only is 75 minus x. And outside of the ring there is 60. So we have to copy this information from Venn diagram. Universal set nu is 150 total, that is n not m is 90 minus x, and intersection is x, say, okay, say, and science is 75 minus x, only science, and finally complement is 60. Okay, outside of the ring is 60. Now as we are going to use formula 2, you can see we are going to use this formula. So first value is 90 minus x, then it will follow with plus x, and plus x will follow by 75 minus x, and 75 minus x will follow by 60, and the sum will be 150. Now we can cancel x and x. We can easily cancel x and x here. So the sum of 90, 75 and 60 is 165. Is it 165? Okay, let me check. Mistake can happen. Okay, mistake can happen. That is, it is 90 plus 75. It is 165 already. I completely missed that 60, which will be 225. Okay, our sum will be 225. So correct it. 2 and 2, 225. And next is 225 minus 150, that is 75. 225, 60, and it's not cancellation, it's mistake, so I have written 22. 225 minus 150, which will be 75. It's not 15, 75. It's 75. It's 75. So maths only. We have to find maths only. Where is maths only? Again, there is maths only. So 90 minus x, 90 minus not 15, 75. Okay, it's 75. The answer will be 50. Answer will be 50. It's 50. So only maths passed in only math is 15. 15 students passed in only math. So number of students who passed in mathematics is 50, not 75. It is 15. 1, 5, 50. So there is no exercise. Let's move to another slide. That is example number 15. Example number 15. See question here. There is only written. It means only. Okay, it's only. Think about it. What will happen if there is only? Okay, now let's start the solution. First, 10 drink only tea. So this is the number of people who drink only tea. None of the other drink. Okay, only tea. Depend only on tea. So 5, only milk. Drink milk only is 5. 2, drink both tea and milk. So drink both tea and milk is 2. And 13, drink neither tea nor milk. Okay, 13, drink neither tea nor milk. That is complement. That is out of the circle. So we are talking about drinking, and if suddenly it comes like not drinking, then it is outside of the ring. Outside of the ring. So let's represent NT as a number of people who drink tea, NM as number of people who drink milk, who prefer milk and who prefer tea, respectively. So let's draw the Venn diagram, and it is for tea, and another ring with overlapping the given ring, that is milk. So rectangle and universal set. Yes. First, we have to always try to fill this part. Do we have information for it or not? Let's see. Yes, both. This is the common among these two. Common among these two. So it's 2. And here, what we have to do? We have to fill. This is the only part, and it's already given only, so we don't have to subtract. Remember, we don't have to subtract only. See, 10, it's already given only. Already given only, so we don't have to subtract. Next is 5. It's already given milk as 5. So only is already given, so we don't have to subtract. If there is only in the question, you don't have to subtract. Up to example 14, or from where we start from 9, I think, doing the verbal problems. Then from 9 to 14, in each and every question we subtract it, isn't it? But here in this question we haven't, because it's already given in the only form, and in the only region we have to write the value, only value, isn't it? We don't have to subtract. So we have complement also, that is 13. So we have each and every information from the Venn diagram. So the first one is universal set, we don't have, question mark, limit, and only t, that is 10, and another one is on complement, that is 2, another only milk, that is 5, only milk is 5, and complement, it's outside of the ring, that is 13, complement outside of the ring. So let's use the formula. We have same formula, okay, no change in the formula. Formula 2, now let's fill the value. 10 plus 2 plus 5 plus 13. Now you will see 13 is 13 and equal to how many? We don't know, so we have to find that anyway. Okay, so let's add how many it is. It's 30. 30 is equal to n. So the total number of people in the group was 30. Total number of people again. We have to find another also, who drink milk. Okay, who drink milk. Where is the milk circle? Again, number of people who drink milk. Where is the milk circle? It's there. See. Okay, now you may say 13 is also in the milk circle. No, exactly, it is not in the 13, it is not in the milk circle. Only these two values are on the milk circle, so we have to add milk. So 2 plus 5 is equal to 7. Equal to 7. So 7 people like to drink milk. So therefore, total number of people is 30, and the number of people who like to drink milk is 7. Okay, that's it. Complete our solution. Now there is one question for you to practice. Only one question. After this there is one more question, example 16, and we will conclude this video. And there are we encounter few mistake, error in the video, but we correct it instantly, isn't it? So I don't think it affected the learning process. So I hope you will excuse me for that, for those mistakes. So let's complete our remaining example. So answer is there. This is the value here in the bracket, is big bracket is answer. So let's move to another slide and let's conclude our video. Now the question you will see on the screen. And the question on your screen is, so this concludes our question. Let's start the solution. First 150. 150 is the total number of people on the survey, or you can see in the group where, to whom question was asked whether you like cricket or basketball, and you can see the another number. There is 100 like cricket. Among them 100 say that okay, I like cricket. Student who like cricket is 100, and 52 like both. So 52 are both, they like both the sports equally. So 52 like both. So let's write 52 like both the sports, that is 52. And 12 did not like any of these two games. See, 12 did not like any of these. They are out of the ring, isn't it? So we are talking about the liking of the any sports, and suddenly somebody came in, oh, I don't like these two sports. Then they are outside of the circle. They are outside of the circle. Do not, I did not like any sports. That is 12. So NC represent a number of students who like cricket, and NB represent basketball, whose number is not given, which we have to find, denotes the number of people who like cricket and basketball respectively. So we are going to find that with the help of Venn diagram. So don't worry about it. Let's draw the Venn diagram first. This is the circle for cricket circle. See, and and another circle is for basketball. Okay, basketball, and rectangle. You will see rectangle for universal set U. Now first we have to try. We should try to fill this place. Yes, there is. Okay, like both sports. Yeah, we have 52 value. In cricket, we have the value of cricket, that is 100. So we have to subtract 100. 100 minus 52, that is 42. So 42 is the number only who like only cricket. So that's only basketball is X. Okay, this X is only basketball. We don't have the value, so we denote it by X. And 12 is did not out of the circle. Then from Venn diagram, 12 did not like both the basketball and cricket. They like all the sports. NU is 50, and another information. NU total is this, and another is only cricket is 48, and only intersection is 52. And as we have supposed that only basketball is X, say, and 12 is outside of the ring. Cricket, union, basketball, complement 12. That's 12. And we have so if we add 48, 52 and 12, we get 112. And we can change the position of 112 from left hand side to right hand side, which is 38. But what we have to find is we have to find who like basketball, means entire ring. The value is entire here inside this ring. Whatever numbers are there inside the ring must be added. So this ring. So 52 plus X is the basketball. Okay, 52 plus X. Number of students who play basketball is equal to, yes, that is 52 and X. Okay, 52 plus X is 38, which is equal to 90. Equal to 90. So 90 students like to like basketball, okay, like to play basketball or follow basketball. total number of students who play basketball or who like basketball is 90. So this concludes our entire video. Thank you for watching. Thank you for being with me. And as I've already told you, there were some mistakes and some noise from the surrounding also. There may be, and some disturbance was there. But still, I don't think it will disturb you from learning. It will hinder your progress. You can enjoy the video. You can learn from this video. And don't forget to like, subscribe, and share. Okay, more video will follow in coming days. Stay tuned. Thank you once again for watching.